Hello everyone. Today we are starting the new chapter, that is thermal properties of matter. Thermal means related to heat. So we need to recall whatever concepts we have studied in lower classes regarding heat and temperature. So heat is what? Heat is a form of energy which gives the sensation of hotness or coldness. Then we have temperature. What is temperature? It is the degree, it is a measure of the degree of hotness or coldness of a body. Right? Now heat flows from higher temperature to lower temperature. This also we have studied. To low temperature body, right? Then we have one concept that work and heat and work are equivalent, and we have a term which gives the equivalence, that is Joule's mechanical equivalent of heat, right? So Joule's mechanical equivalent of heat, for understanding that, it says that work and heat are interconvertible. We also know that when we rub our hands in the winters, heat is generated. So whatever work we are doing is converted into heat, which is generated in our hands, right? So we can say that work and heat are interconvertible, right? So we can say that work is directly proportional to the heat. In other words, we can also say that if we remove the proportionality sign, we can place a constant of proportionality. This J, which is the constant of proportionality, is called as Joule's mechanical equivalent of heat. Right? So we know that SI unit of heat is joules, but CGS unit of heat is calorie. And we have this conversion factor for joules and calories. We know that if J is equal to 1, then W is equal to heat produced, right? So from here it is observed that 4.2 joules work is done by 1 calorie of heat. So we can say that 1 calorie is near, it is actually 4.18 something, so it is nearly equal to 4.2 joules. Actually it is 4.182 joules. So this is a conversion factor which may be used in numericals, right? So this was all about the basic concept of heat and temperature. Now we have to discuss about the temperature meters, or the instrument which is used to measure temperature, right? So that is thermometer. So thermometer mein we have different temperature scales. We have 4 types of temperature scales which we have to measure, right? So the instrument which measures temperature is thermometer. And we have 4 type of temperature scales which we have to discuss here. The ones which we have to discuss are Celsius scale, or this is also called as centigrade scale. Then we have Fahrenheit. Then we have Kelvin. And then we have Reaumur scale, right? So for all the 4 scales, I'll draw the diagram for the conversion factors. So first is now this lowest point is marked as the ice point for all the scales, and this upper point is marked as the steam point for all the scales. So this is marked same for all the scales. See, whichever unit we are measuring. So if this is the ice point, this is a steam point, that point will remain the same. The numerical value will depend on which scale we are taking reading in, right? Then after what was done, this was marked as 0 was marked as the ice point for Celsius scale. 32 was marked as ice point for Fahrenheit scale. 273.15 was marked as ice point for Kelvin scale, and for Reaumur again 0 was marked as ice point. For Celsius scale 100 was marked as steam point. For this is 212 was marked as steam point, and for this is 373.15 steam point, and This one is 80. Then whatever is the gap here between 0 and 100 was divided into 100 divisions in case of Celsius scale. In this case, it was divided into 180 divisions, and here it is 100 divisions, and here it is 80 divisions. We don't have to derive the formula, we just have to learn the formula, but I'll tell you how to learn that. Now from here, value in the given temperature scale, that is Celsius scale, minus ice point. I'll just write the general formula first. Value in the given scale, or you can say temperature in the given scale, minus ice point upon total number of divisions. So this we are using for every thermometer, and it will be same, because whatever is the difference between the particular temperature in given scale minus ice point, so this will be same for everything, and total divisions, this and this, will also be same. So this ratio will be same for all the 4 scales. So temperature in given scale means, if I am writing for Celsius, this is Tc, minus ice point is 0, divisions is 100 for Celsius. Then we have Fahrenheit, here temperature in Fahrenheit minus ice point is 32, divisions is 180, is equal to temperature in Kelvin minus ice point upon divisions. For Reaumur also, temperature in Reaumur minus ice point upon 80 divisions. So we can cancel the common ratio. This will be cancelled, this will be cancelled, this will be cancelled. So this will be 2 5s are 10, 2 9s are 18, 2 5s are 10, and 2 4s are 8. So we can simplify the formula. This will be Tc upon 5 is equal to Tf minus 32 upon 9 is equal to Tk minus 273.15 upon 5 is equal to Tr upon 4. So this gives me the formula for converting the value in one temperature scale to the value in other temperature scale. Right? So we can take a question over here. Find the temperature at which the Fahrenheit and Celsius scales have same unit, same value. Celsius right? So let's find out Celsius, that temperature I'm marking as, let's mark Tc is equal to Tf is equal to T. If these are same, so I'm marking T upon 5 is equal to T minus 32 upon 9. So this gives me 9T is equal to 5T minus 5 to the 10, 0, 1, 5, 3, 15, 16. This gives me 4T is equal to minus 160. So temperature is minus 40. So at minus 40, the value of Celsius and Fahrenheit is same, right? So this was all about the temperature scales. Now we can define the absolute zero of the temperature. This Kelvin scale is also called as absolute scale, right? For that, I need to rub the left side of the board. Now, if we plot a graph between pressure and temperature for a gas, so what happens is, this is the pressure, and on the basis of experimental values, the graph comes out to be like this, right? So if we extrapolate the graph on the basis of the experimental results, it is observed that this graph cuts the temperature axis at the value minus 273.15. So at this temperature, the pressure is 0, right? So this temperature of minus 273.15 degrees Celsius is defined as absolute zero temperature at which the pressure is 0, means all the molecular motion stops, right? Because if we look at this temperature in Celsius is minus 273.15 when Kelvin temperature is 0. So I'm just marking this as equation 1. We can just mention it from equation 1. Temperature in Celsius is minus 273.15 if temperature in Kelvin is 0. So that is why the Kelvin scale is also called as absolute scale of temperature, right? So this is this was all about the temperature scales and absolute zero. That's all for now. Have a nice day.